Hello everyone. Today we're going to talk about Secure by Design. Secure by Design specifically focusing on next generation build environments. So we're going to take you through what the advances in build systems are and where things are going in the future and all the things that we've accomplished in the last year. So my name is Tim Brown. I'm the CISO for SolarWinds and I'm joined by Paul Gray.
And I'm the VP of Architecture at SolarWinds.
So we really need to start thinking differently. When we look at all of the things that have gone on in the security area for the last year, if you look at our incident, if you look at Log4j, if you look at Colonial Pipeline, all of those things really point out that we need to do things differently. We can't look at security the way we looked at it a year ago or 2 years ago. We have to do things in an exemplary manner. We have to do things in an assumed breach manner. We really have to just essentially bump up our game so we're resilient to all different types of attacks. And really Secure by Design starts with that. So, Secure by Design in general looks at a number of different topics in different areas. We'll cover those and then we'll dig into the build systems. So when we look at today's IT climate, right, everything's changing. Everybody's going from distributed to distributed environments. Everything is hybrid, right? Nobody is utilizing just on-premise environments. They all use some form of cloud. They all use some form of people being in different places. With COVID coming in, you look at everybody working from home. So we quickly adopted an environment where we have remote workers. And with remote work, we now even have more of a hybrid environment. So those are the types of transitions we look at. And from an IT perspective, transitions end up causing us risk, right? They give us a different thing to look at. They give us the idea that everybody accessing data from anywhere, in anywhere, just becomes extremely risky for us to think about. So how do we effectively, protect in those environments? So that's one of the keys that we start looking at. Beyond that, right, the threat environment has greatly evolved. And when I say greatly evolved, what I mean is that the motivations have become much larger and the threats have become more subtle and the threat actors more sophisticated in what they're doing. So very important to think about that sophisticated threat actor. Everyone should always take care of good hygiene. But when you look at the large incidents that have occurred in the last year, they've been very focused. If you look at the ransomware against hospitals, if you look at Colonial Pipeline, if you look at our incident a year ago, each one of them had a threat actor that was patient, that took their time, that learned the environment, and then we're looking for big impact from them, whether it's a $5 million ransomware payout, or affecting many different machines. The payout at the end is worth the input that they put into. So when we look at those types of threat, the evolution of the kind of threat environment, we say, wow, how do we do things differently? How do we bump up our game? What do we do that we can really move forward from? So very important, and a lot of things have come out of that. So when you look at some of the things that have occurred, the executive order on security was published about 2 months ago. With that, they're looking for more working together, more collaboration between the public and private companies, and looking at sharing data better, looking at having more information flow so that we can essentially protect everybody in a better way. But the threat environment always evolves and continues to evolve, and we have to expect that occurring, forever. So we have to adjust for that and take care of that. The way that we do that is really by, focusing on Secure by Design. So what is Secure by Design, right? How do we evolve with Secure by Design? So part of it is ensuring the integrity of our build processes. That's kind of one of the steps of Secure by Design, making sure that the build processes are beyond reproach. So those build processes are extremely resilient to attack. And there's a number of factors we do with that. Very important to share learnings, right? Very important to share amongst everyone, what we see, what we have seen in the past, the places where we're going to make things better. So very important to share, and share learnings to as many folks as you possibly can. And that goes with our partners, our community, and our customers as well. Leveraging and contributing to open source initiatives, a big part of Secure by Design, making sure that we are contributing back, that we're making it easier for other companies to achieve the same things that we have in our build environments and build models. And always leading by example, right? That supply chain issue, which we saw, in December of 2020, when we look at that, then we look at the supply chain issue of December 2021, which was Log4j. And we expect to see more and more of these supply chain issues as we go forward into the future. So the more experience we can give others, the more we can share with others, the stronger everybody becomes. So that's really a big part of Secure by Design, a focus on our environment, a focus on the industry, and absolutely 100% focus on our customers as well. So let's talk about the build environment. Yeah, the build environment and the build environment of the future, right, really looks at 4 different tenets. And we're going to dig into each one of these tenets separately. So first tenet is base the system on ephemeral operations. Ephemeral means that nothing is static. Nothing is there that's static. Nothing lives for a long time. So that's what we mean by ephemeral. Ensure the products are built and produced deterministically. We'll talk about what deterministically means in a couple minutes. Build in parallel. Talk about what that means and why you have to build in parallel. And recording every build step. So those are really the 4 tenets that we came across for building an environment. One of the other major tenets, right, is that developers shall have fine-grained control over the things they build. That means the developers can still do their job. They can work independently. They can move fast with what they're doing. They have fine-grained control over the things that they build, but they have zero control over how things are validated and secured. That's a very, very important tenet to think about. That means the developers can move fast. That means the developers can share with other developers. That means the developers can build systems. That means the developer doesn't stop doing their job. What that means, though, is that they're not responsible for security and they're not responsible for validation. And that separation of duty gives us one of the strongest tenets of securing the new build environment. So Paul's going to take us through some of the details here. So, base the system on ephemeral operations. What does that mean?
That means basically take the state, make sure everything is stateless and everything is very short-lived, right? So we looked at a lot of different build systems. They're coming a long ways, but there was, one out there, Tecton.
And those who don't know stateless, what does stateless mean?
Stateless means there's nothing there like a database or something like that that you have to save something between build steps.
Got it. So you just have a rebuild it every time. So nothing is static, everything gets built.
Everything should be built in containers, really, in general. And
what advantages do we have putting everything into containers?
Because one is very short-lived and they're ephemeral. Plus, depending on which build system you use, you can separate security from the actual build. So no developer, internal actor, or inside threat can do anything harmful. They can define their build, but they can't do anything as far as something that will harm our build system, right? So separation of duties.
Separation of duties, right? Yeah. So with separation, and go ahead, go into the technologies that we tried and that we ended up utilizing.
Sure. We went through a lot, but realistically, nobody met all of our needs. We probably were spun up too much initially, but we tried a lot of different build systems and we settled on Tecton that's being driven by Google. It's an open source initiative, I think, between Google and I'm not sure who else, but for sure by
others.
Google.
Right?
Others.
And so what does Tecton give us? What does it do?
Really, the best thing it gives us is the ephemeral nature we need and the control plane separation. There's a control plane that has security elements, and then there's the sort of build environment that the developers can control, right? They have access and they can control that, but they can't do anything malicious outside. So any signing material, any keying material is all held outside.
And Tecton manages that?
Tecton manages that for you. And other build systems are coming around, but initially Tecton's the only person that actually had that. So developers can't do anything malicious, or somebody like in Sunburst that got into our system couldn't do anything malicious, right? They could only do a build. They couldn't do anything else. They couldn't jump around.
Got it. Excellent, thank you. All right, so the next one is deterministic artifacts.
Right, that's being able to build in two different places with all the inputs defined and getting the same bits out.
And why is that hard, right? You'd think that would be
It's
just
very
like,
hard because
I'm building once, I've got the same code, I've got the same, why would they be
the
different?
hardest thing is timestamps. So different languages have different ways to timestamp, and so it takes the current time. So you gotta strip that out. That's one of the biggest things is when you compile it, it includes the current time, and the current time will always make something non-deterministic, meaning the bits don't look the same on this build system as this build system, really based on time. There's a lot of other things. Each language has to be tackled independently, right? So, we support many languages, so we're going through the process of Java, Go, C#, C++. Each one of those have a different route to being fully deterministic, but you can do it. It's just not easy. The new standards that are actually coming out don't really require determinism because it's really, really difficult, but it's the thing that burned us in Sunburst, right? If we knew, so we're really spun up on determinism compared to other builds or other build vendors or other build standards that are coming out there. Most build standards that are coming along don't dictate determinism. It's a nice to have feature.
Right. So
not for us. So.
Yeah. So just to rewind a little bit for folks. So why we're so focused on the build environments and the build systems, with Sunburst, what happened, our source code was not affected. So nobody changed the source code that we then checked out and essentially built. What they did is they inserted themselves into the build environment at a certain point, essentially in a worker thread, to be able to insert code in there, which we then took and signed and built and shipped. So when we look at solving this problem, deterministic builds are a critical component for us to make sure that we can check between different systems building the product and say, yep, it's identical in each one of these things. And we'll talk about parallel next. That leads us into why build systems are so why deterministic is so important. I'll start with the simple one, and then Paul can go through and talk about why it's so important. When we look at deterministic, right? If I have a build that's a deterministic from my standard pipeline, my security pipeline, my validation pipeline, it doesn't matter what I do in between, right? Each one of those pipelines, one could take 10 minutes to run, one could take 10 hours to run. But at the end, the bits are going to match between each of these. Now, when you add the security context of saying no one person has access to each of these builds, now in order to affect our build, you would need collusion between 3 different people having access to each one of those systems to affect the end result of the build. So now this becomes a very high bar for anybody to affect and anybody to change in the middle. So that's why it's so important to be deterministic, to be able to allow the parallels. So talk about the parallels and all the pieces that we've got.
Sure. Real quick though, just over on the left-hand side, there's nothing about the build system, but we did a lot of work going into this build system about our source code. We converted all our source code to GitHub. So our source code was split between Bitbucket and GitHub. So we moved all of our source code to GitHub, and we applied automation onto the repos. So all code has got standardized setup and standardized security across all our products. Before we had half and half, and there's no way to really audit that. When we did that, we also send all of our auditing to Tim's SIM so he can look over our shoulder. But there was a lot of setup that happened on the way to this new build system. We also went to monorepo as well. So we combined all of our repos into one single monorepo, which gives us a really good ability to do systemic changes. And we can fix a bug once, where before we'd have to fix it in 5 different places. So we had a lot of cross-site scripting bugs or things like that had to be fixed in multiple places.
Yeah,
now with the monorepo.
Let's talk about the modern repo model, right? And what that means is, when you think about some Orion, 12 different products, right? Each one of the products, not all of them were different, but a number of repos in play for, just building up Orion. So what the modern repo says, okay, I got one library, right? I've got one version of this library. If I change it, all the things going to pick it up automatically. So an incredible amount of work to be able to combine and condense down to one repo, but the benefits are huge, right? Benefits are huge from a security perspective, an update perspective, and a simplicity perspective too. Just a lot of work to get there.
Yep. It also simplifies the build. A lot of the build systems, we have 40 different products, so we're trying to incorporate 40 different products into one build system. And so Orion's the most complex, and so with all the repos we had, the complexity in the build system made it very difficult to migrate over to a new build system. So going to monorepo makes it pretty easy to migrate to any build system.
So why don't we talk a little bit about what open source gave us here, what we had to build,
Sure.
And kind of those details.
Sure. So really the standard pipeline is what is the biggest part that the open source product gave us. So it's a build pipeline, and outside that build pipeline, it has something called chains. Chains give us the ability to pull out secure information or high access level away from our developers. So that top build pipeline, the standard pipeline, is controlled mainly by developers. They can only control build steps. They can't do anything else. But the thing about that, they totally control that pipeline, and we don't do anything to them. We let them build as quickly as possible and give them results. Even if something fails down the line, we don't try to impede their process, right? We're trying to cater to the developers on that top pipeline.
Well, it's speed too.
Speed,
right?
yeah,
you
exactly.
Hit a button, you want to build,
and
right?
they don't have to worry about keying material at all. They don't have to worry about attestations. They don't have to worry about any of the stuff that's really difficult to share crypto information with them. They don't have to worry about that. It just happens for them, right?
Yep.
And then part of that is a security pipeline that's controlled by a security ops team. So when a build starts in the standard pipelines, we mutate that build into the security pipeline, and then it runs things like white source and check marks or any other scanning we have. It'll actually it does that independently. They don't know anything about it. They don't have access to it, and it writes it to this metadata service down here, the blue box down there. Everything's stored in a metadata service. So the developer just checks in his code, runs his build, goes about. If it compiles, it's successful. It may not be released, but it is successful, so we don't impede their process.
Yep.
Then the security pipelines mutate it. There's also a mutation that happens on the validation pipeline. The validation pipeline at the bottom is in a different cluster, so there's very few people that have access to that. The middle pipeline is SecOps owned. The bottom cluster is owned by very few individuals, less than 5 people in the company, right? And they're not the same people that have access to the standard pipeline or the security pipeline, right? So we have another mutating build there. All that's doing is the determinism or reproducibility. So again, it might fail on reproducibility, but the developer doesn't know. It writes that information to the metadata service. And then we have a secondary, another service that comes back and queries all the data out of the metadata service and evaluates whether that artifact can be released to SaaS or can be released to our Akamai or to our production customers for on-site.
So the end result is that the no build is released to customer before it goes through security validation pipelines, and they have to match essentially the same bits from the standard pipeline, security pipeline, validation pipeline. So each one of them can take longer, right? Validation pipeline can take long time to run. Security pipeline as well, but with the developer pipeline going fast, you don't impede their progress. Yeah, why isn't this standard? It just really has not become standard for everybody to do this type of build model because a lot of the pieces didn't really work well, right? So we took as much as we could from open source, but if you notice on the chart, you'll see some things that are in, let's see, what color? Yellow, that we did. And we had to build. So what were those things that we kind of had to build?
Really just the sort of mutating builds. So the things that integrating with the GitHub, knowing when somebody checks something in, whether to do a pull request, when do you spin off these other builds? So, and being very secure and not letting developers have access to that. And then our OPA, we're leveraging an open source evaluation engine as well. So we wrote some tooling around there. The metadata service, it's halfway there, but the ETL service, if you will, like extracting the data, putting in the proper format, putting it into immutable data store is not there either. So if you want to, if you want to meet the government's mandate about having a immutable data store, you have to do a lot of that on its own. Again, the open source is good. It's sort of that freemium model where they want They want you to come in and use it and then actually use the paid-for service. Even the paid-for service doesn't have as much as our build pipeline has today, but it required us to spend a lot of time writing these tools. But the good thing is we're positioned good for the future. Like the future of SBOMs can come directly out of our metadata service.
So SBOMs essentially are, I don't know what this SBOM stands for. Standard SBOMs,
Software bill of material.
Software bill of material. Thank you. Software bill of materials is all of the libraries that are shipped with a product. And a number of, like the executive orders mandating SBOMs starting to be produced for products. So what that means is you get a bill of materials that says, okay, I ship these libraries of this kind. So this SBOM creation is truly real. It's everything that is included in the product itself. So important components to it. Important for us to be able to do things utilizing open source, but then extending upon it. So I think the recording every step, you talked a little bit about that. But go ahead with...
No, that's why it's so important, because the specifications of what should be in an SBOM have not really been published from the government, but there are standards out there. You can go very deep, so not only the depths of your software, but the depths of third-party components. You can also use it for licensing. You can use it, for like in Toto or attestation. So there's a lot of things that I think eventually the SBOM will be used for, but there's really no specification. So this is why it's really important for us to record everything. Who checked out the code? Who reviewed the code? When did the pull request happen? What was the compiler version? Everything. What was the build? Who checked in the build steps? Who checked in the cluster build? Who checked in the VPCs? All that stuff actually goes into that metadata service, and we can pull it out. Again, I think eventually they'll want all that information.
Right.
Our customers, our vendors, or GSIs will want all that information. We should be able to give it to them in the proper format.
Yeah, the other part that's important is that data is immutable. The data can't change, right? The data is protected. So that's the other thing you always look for in security, is that the data itself is trustworthy. So having data from the independent systems come into a common store allows us to ensure that trustworthiness of the data and give us a host of information to be able to monitor and watch and control to make sure that there isn't anything going on that shouldn't be going on. So a number of things that we've also been doing is sharing our learnings with the community, customers and partners. And really when we look at that sharing that we've been doing, it breaks down into a number of different areas, right? How do you prevent things from happening in the first place? What controls do you put in place to make sure that you can have good visualization across the environment, that you can really see what's going on across the environment, that you can help circumvent things there. We did things like go to multi-tiered MFA, where all of our administrators now have YubiKeys that are stronger than SMS, stronger than Authenticator. The YubiKey gives us kind of that model of a true multi-factor auth. We did that. In the security teams, we went for visibility across the board. So visibility, we have visibility that's provided for us from CrowdStrike and their service that runs on every workstation and server. We send that information to SecureWorks, who operates a SOC and then takes our AWS information, our Office 365 information, our application information, combines that together. And then at tertiary, we have MySOC, and MySOC is that third set of eyes. So we want to make sure that we have strong visibility across the entire environment and that we're really able to see any anomalies there. We also instituted a red team that actually tests that hypothesis all the time, and a full-time red team to be able to look across the environment and make sure that our development environments are secure, our infrastructure is secure, our other environments are secure, and that they're trustworthy. So the red team allows us to test this constantly moving forward in testing. Preparing, that's one of the ways you prepare. Prioritization, what do you prioritize first? What do you do first? How do you manage through, how you deal with both incidents prior and incidents that are very important. One of the things that we also learned is how to communicate. Communications has been a challenge for many. And, one of the things that we noticed was that we went through Log4j this December. We had a website stood up inside of our trust center very quickly, right? We had information on what products were affected. There were two. We had information on how to hotfix them and patch them out themselves that the customer could do themselves. And that happened, I believe, a day, 24 to 48 hours after Log4j got announced. We had, here's how you can update the libraries for Log4j yourself. And then within a couple of more days, we had hotfixes that were shipped, were complete products. And we just kept up on it. But we had our Trust Center page up. We notified everybody that's in our security notification pages. We did great communications on the way out. And it just went smoothly because of that experience of the past, knowing how to communicate, appropriately communicate as often as possible. And then we always evolve, right? When we look at evolving, evolving from the build system is a good example, but we always continue to evolve in everything we do to try to be exemplary in a number of different aspects of security. So, open source initiatives that we have leveraged.
Yep, there are many here, and we continue to contribute to these efforts and participate in other even industry standards as well.
Yeah, the way that I like to say is we're not a driver, but we are a player, and we are a contributor, and we are a user. But we're not going to go own a big initiative, right? It's just kind of not.
We never had done that as a company really in the past. We haven't contributed that much to open source, but since Sunburst, we're trying to make the whole community better, right? We're getting value from them, but we're also contributing back to these various vendors.
Yeah, and I think if you look at a lot of the kind of different initiatives that have been going on, Microsoft sponsors some of them, Google sponsors some of them, they're all heading into that same things that we talked about for the build environment. They're just doing things slightly different. And
let's hope they evolve to IETF or IEEE or something that has actually, there's a lot of good work. There's just not a standards body that's unified all these things together at this point.
Yep. So leading by example in the secure supply chain, we've established new standards for software development. We're collaborating, continue contributing to open source efforts. We're holding the lamp in our community vigils against threats, right? We keep calling out where we see threats. We're calling out where we can, improve. We're trying to be as transparent in the industry as possible, about what happened with us and how people should think about it and what they should be doing to prevent those types of activities happening themselves. And, we're absolutely advocating for public-private partnerships. Now, we haven't figured it all out on the public-private partnerships, but we have hope. And we are, proactively trying to help in establishing the correct kind of the cadence, the correct model to share, the correct things to share. So we think public-private partnership is an important way for us to move forward, no question. Always believe, ending statement here, that a well-managed environment is a secure environment. So it is very, very important to think about the knowledge that you have, the knowledge that the SolarWinds products give you. Although not necessarily security tools, that information is invaluable. The ability to well manage an environment and understand what is in that environment and figure out, hey, is this a performance issue or is this a security issue? So it starts with the data, starts with the knowledge that you have. We're going to be talking more about observability, as the day goes on. And when we look at that, looking at more into the hybrid world, and kind of that linkage between the on-premise world to the hybrid world, very important, and solving extremely important problems that the complexity of today's environment have brought. So always remember, a well-managed environment ends up being secure. If you're not well-managed, there's no way you can secure it at all. Now, if you'd like more details on the secure development environment, there is a white paper. The link to the white paper will be in the deck that you saw. We'll make sure that it is available. It's open, it's public. Again, we're trying to publicize things that are important and publicize them to everybody in the community. So additional key resources for you are highlighted in the outtake here. Becoming Secure by Design, IT Trends, Secure by Design Resource Center, and our SolarWinds Trust Center, which is updated for things like 4J and any events that might occur in the world. So I want to thank you.
Thank you very much.
Thank you, Paul.